Wait, you were supposed to fall on the ground.
He was a skater boy.
Liam's walking up the hill because he doesn't know how to ride a skateboard. He's been bragging to us about his ollies, but it took him like 2 minutes and he couldn't do one, so we had to move on to something else for our forces video. Dude sucks at skateboarding so bad. Complete trash. Watch, I wouldn't be surprised if he fell right now.
We should just do that rest. Is it gone?
Yeah.
Alright, so the first question, what is tension in the string? We know that on the box, it's not moving, so sigma F equals 0. So you take the box, and you know both the forces on the opposing sides will be equal. So we got tension, we got force of gravity. Force of gravity equals M times G. Box is 10 kilograms times 9.8, or 10, I guess, on the AP test. You get 98. So tension equals 98 or 100 newtons, because that's what it is on the key. We'll say 100 newtons. You know if we can see the second question?
Yeah, you see the whole picture.
So we know we got force normal, perpendicular to the surface that it's on. We got force of tension going that way. We got the force of gravity going straight down. And then we got force of friction. And of course, with the force of gravity, we know we got to do like the sine stuff. And so you take the, because there's going to be gravity going this way directly into the surface, and there's going to be gravity going directly down. And so what you do is you take 100 cosine 60 and 100 sine 60, because that's up here, and we know that because they give us the angle. And then we know this one equals cosine 60 equals 50. They give it to us, so 50. And 100 sine 60. Sine 60 is equal to 0.87. Multiply that by 100 equals 87. And so we know that the force down now. So here, I'll just redraw the box on it. Let me draw it over here. We got the force of tension. We got the force of friction. We got the force of gravity, say X. The force of gravity, Y. And we got force normal. And so, yeah, that'll help us in the next question. So we know the magnitude of the frictional force on the box on the plane. So we know the force of friction plus the force of gravity in the X direction is equivalent to force of tension because it's not moving. And force of friction, we don't know. We know force of gravity in the X direction is be 87 equals 100. So force of friction equals 13 newtons. I had to re-look at my notes, so we'll just have to cut that out.
That's all right.
Alright, so for this one, we know that the box is now moving, or the box, whatever. And it's moving down the thing, it's that way. So let me draw a good free body diagram for y'all. This. So at the force normal, and then the force of gravity and the y. These two will cancel in the end. Oh, we got now force of friction is going this way because you know it's moving down. It's gonna be like scraping up against it and stuff. And so then the opposing force would be force of gravity x. And so we know sigma F equals force of gravity x minus force of friction. So we know this already be 87 minus 13. Sigma F equals 74 newtons.
If you have to restart, you can use the other form.
Man, I gotta do everything else again. So shit, I'm gonna scratch this out. We'll just cut all that. Is that good?
Yeah.
Alright. Alright, so we got force of friction is the only opposing force as to the force of gravity in the x direction, because we know y and force normal, or force of gravity y and force normal cancel out.
I think it's boss.
And so now because it's moving, we know that the force of friction is kind of different now. We know it's got to be force of friction equals mu Fn. And so we know the new force of friction equals mu Fn. So force of friction equals 0.15 times force normal. We know force normal is going to be equal to force of gravity in the y direction, which is 50. So we know force normal equals 50. And thus force of friction equals 7.5 newtons. And so to determine the unbalanced force, we go back to this. It's got to be force gravity x minus force friction. Force gravity x being 87 minus 7.5, which equals 79.5 newtons. Alright, so for this one, we gotta do kinematics and stuff. So sigma F equals ma, right? We got the mass, which is 10. We don't know the acceleration, and it equals, we got up here 79.5. So you divide that by 10, acceleration is equal to 7.95. And so you plug that into a well, I guess let's find our variables first. So we got our acceleration equals 7.95. Our distance equals, I forgot, let's look back up. It's 2 meters on top, up here. And then our V1, because it starts from rest, is 0. So we need the speed when it reaches the bottom of the plane, so it would be V2. And so here we got V2 squared equals V1 squared plus 2AD. And we know there's nothing here, so that cancels. We got V2 squared equals 2 times 7.95, because that's the acceleration. We got that right here. And our distance, 2 meters. So that's 4 times 7.95. I don't know. 4 times 8, 32. 4 times 0.5. 31.8. So V2 squared equals 31.8. And I don't know. Put that in. Take the square root of each side. And we got V2 equals 5.64 meters per second.